Okay, here we are on November session number 24. Okay, welcome back on this little experiment we're making during this lockdown and the November. Oh, forgot to cut the sound here. Okay. Tea a little bit hot. Some jazz, and let's shake. Go back here, okay. Without any export, so it's okay. So yesterday we made a little guy, not without any difficulties because I was a little bit tired, but we made this little guy which is quite smooth, and the main idea was to have some kind of soft body shapes made of sphere with displacements, with no displacements, and having this kind of a blobby growing system. And tonight I think I would like to go back to something we've already explored, but with more detail. Let me show you what I mean. I think I would want to basically explore something quite, how can I say that? Quite well known, in fact. It would be to explore some particle man. So we have this one. I've tried to avoid to simply going to making a particle man, but as we are reaching the end of this conversation, this idea came back in my head, and I so maybe we need to sketch it. So it would be a little bit different than this one, but a little bit like this. So yeah, this is the only particle man we have. So yeah, for this one I was inspired by the movie Spider-Man 3, where you have this Sandman which is growing himself, and it was one of my references when I was a student, because I was amazed by the way the Sandman can grow. But this one I want to make something really more simple. So the main idea is having a particle man with a lot of particle, of course, much more than that. Really small particle, maybe having something really like a Sandman, basically like a Sandman, and the particle will always fall, maybe at different speed, and the main idea is to create something like a rainy man, someone which always lost things, which always lose some particle every time. So we'll have a lot of particle, and every particle will just go down and bounce to the ground and disappear after a certain amount of time. And I was thinking about another thing, but I'm not sure about that one, is maybe using what we've made lately, which is maybe revealing the body using the normalize 8. And I had this idea about using the sine distance field to getting a cube, and the main idea is having a rotating cube, and when the cube is going from the ground to the head, inside the cube we can make some particle appear. So we would have some kind of a plane plus a cube turning on itself, and we will have this kind of shapes. But I'm not sure about this one, because I think by making a particle man we would have something really how can I say that, empty, because the particle will spawn on the body, not inside. So it's basically an empty man. It's not make a lot of sense. So I'm not sure about this part. So, but the part about the sand which fall, I'm quite sure about this one. And as this idea always come back in the back of my mind, I thought it would be a good day to do it. So let's do that. Okay. As again, let's take few seconds, few minutes more like that to prepare our little scene, which is basically, I'm just, for every stream I'm saying that, but basically what does it mean? It's simply take this actual scene, save it into a new one, which is the 1124, and basically we will duplicating the GPU mesh controller, the shaders and everything into a new script, changing the names, and then we then go back. So that's the idea. Okay, so here we are. Let's start with the scripts. So the compute shader, the vertex, the material, okay, the controller, and the GPU mesh controller, which is here. Okay, now we can open everything. We would need this one. We would need the controller 24. Also, we will need the instance surface. So rename this by 24 and this one by 24. Okay, go back to the controller. Take all 24 elements and rename them as 23 elements, sorry, and rename them as 24. Something in the throat. Nothing that a cup of tea cannot solve. And then this one. Okay. It's okay. So now we could change that. So let's remove this component. Yeah, we are on the right way. I also need to create a new material, so the 24, and saying that it's use the shader. Okay, so go back to our little experiment. So put the controller, put the GPU mesh controller. At first, let's say 100 of instances, just to be sure, and we would say something like a size of 2 by 2 by 2. Okay, a min scale of 1 1, size 1 1 1, 1 for this. Let's put the color also as 1. Let's put the compute shader we need. We need a body ramp, so again we would use a body ramp, which is, where is ramp 1D? A random one, for example. A material, it's the 1124, and we would need a mesh. And for the mesh, I was thinking about taking a simple mesh like this one, because sand particles are not really sphere, you know, it's more like little rocks. So something like a little rock might be interesting, but as I need not too much vertices, something like that, 182, 180, 200, 200, 200. I think we would take it later, but oh yeah, this one is correct. Let's use this one. Okay, now that we have this one, we can try our little script. Okay, so this is basically what we had yesterday. It seems that the stream on Instagram has shut down. So let me relaunch it. But if the stream is basically shutting down so quickly, it might be complicated to pursue our little experiment. But let's try. I will relaunch this, and we will try to see what happened. Okay, let me copy this to my string key. Okay, I will keep this on my phone as a monitoring system. Can I put it? Yeah, I think I can put it here. Okay, so yeah, this is basically the same things that we've made yesterday. This is correct because we are using the vertex shader, which has a displacement on it. So let's get rid of these parts. Okay, we don't need that. Also, we don't need that. So that is okay. Then on this one, I think we only have the albedo, which is on the ramp. So right now, let's keep the ramp active. So by that, I think by disabling the vertex displacement, we would only have the growth system. It looked like a playground man, you know. But yeah, let's go now to the compute shader, and now we would change. We will change, in fact, not would. Yeah. So now the color is okay. The rotation, let's comment that part, and let's the scale. For the scale, it's comment the part where we are simply changing its size. Let's comment it instead of deleting it, just to be sure. Okay. So now I could have simply our instances on the mesh, so that is okay. Then we could find the last the smaller value for our little elements. 0.5 might be a little bit, 0.1 might be a little bit too small, but something like that. I want like little rocks, so maybe a little bit too big, especially if we have a lot of them. So let's try that. Now it's kind of better. We have a feeling of having something with some thickness, so that's okay. I think a size of 0, 1 as a minimal size might be also a good choice. We have something like that. Okay. So now we can basically increase the number of elements we will have. Say something like 5,000. And if you want a very thick element, I think we would need to to reduce this offset here, because we have this random pose here. The random pose, remember, the random pose was simply an offset for each instances in order to avoid to have two instances on the same spot, so it will have this flickering due to the fact that that's two planes are on the same spot. But now it's kind of better. As you could see, you now have more elements. Let's increase more. 10,000. We are still on good stat for 10,000. As you can see, 10,000, it's clearly clearly enough. Yeah. 60,000 might be too much. You need to remember that we are spawning a lot of elements directly into the body, so yeah. So yeah, with this one it might be interesting. Right now it seems some of them are, maybe we can change a little bit the body, because remember we are spawning on the vertices. So basically when you have, how can I say that, a big hole inside the triangle, we will be on the vertices and not on this. So on the chest it will be too much element, but we could change. In fact, for this one we could go back with, remember, this base mesh, but the dummy was, yeah, the dummy was quite interesting, but again too many, or maybe David, simply the David. But again, it's not really it doesn't have it doesn't has an even distribution, so we would have more element on the foot. Oh, I think in fact this one might be enough. Increase a little bit, maybe adding 10,000 elements. We're still reaching a good frame rate for that one. So for me it's might be enough. And maybe we would create a new body in order to subdivide it and to have more evenly distributed elements. Okay, so the next part should be quite simple, in fact, because we have the velocity, we have the acceleration. I've keep them bound to to the compute shader because I was thinking about maybe we would use them later. So yeah, so which one is let me check which one is it. We are working on the where is it? So this is the so this is 23, 22, 21. So yeah, it's 20. It was the 20 that we when we used okay, the fold down system. So go back to the shader 20 and we add all these sims. Okay, so we add this gravity, position and that. So let's put this here. We don't need this and this because we don't need this anymore. Okay, so this is the fall. Okay. This is the rotation, this is the offsetter, so this is the spawn location. I think we could respawn this directly every time we're reaching the end. So this is gravity and we have other forces. So this was the forces. Max deviation, max gravity, okay. Force params. Okay. Let's check. The gravity is here, the friction is here, so not a problem. Max deviation is defined here, max inverse gravity is defined here, so this is for the edge. I forgot to take this part, so yeah, this part is when we check the edge. I forgot that, so this is this. We check edge here. Okay. Max speed. So we use the max speed only. I think we have a random force offset which is here. So the mean force is not used. The edge force is not used anymore also. We don't use the curl right now. And the mass is clearly not used also. So let's try to get rid of this. And let's try this. So yeah, compute and declarifier ramp size. What's the ramp? The ramp size was on the top. Okay. So the fall is okay. So let's change that by reducing really a lot of the elements. Let's say only 10 to see. Yeah, you can see they are moving really fast. They're smaller, so they will need a max speed really small, I think. This is the max deviation, in fact. So mean inverse gravity, maybe something like more value. Sometime I found one of my script too complicated. Okay. Yeah, they're moving a little bit, so it's okay. Let's add less friction, because with less friction we would have more bounce. Does the friction need to be divided by the mass? I'm not sure about that. Okay, so let's go back with our 35,000 element. As you could see, it's I think the problem is the gravity is, yeah, this is the problem. The gravity is too much. Okay, so this is the main problem. Let's, oh yes, that's all have the same timing, so let's use a timing of 4. And yeah, the gravity so we could also basically multiplying this by -2, for example, if you want to increase the bouncing. Okay, we are near something interesting now. Okay, so this is basically what I wanted. So now we could also try something like that. Let's say that float mass is basically linear interpolation between something like 1 and 5 using the RAM size. So this could be a way, and I was thinking about maybe divided the force with the friction force and the reflection force by the mass in order to have something a little bit different. Okay, that's interesting. I'm not sure about this one, but the rest is interesting. Okay, so now we could use a new time, and we could offset this a little bit. So let's say it's something like that. So let's say every element will be between 2 and 4 seconds in order to reach their time. Well, that was the idea. We could try to change the shader because we use the ramp, and the ramp was basically the random value here, so every time it's going back it change the color. But if we want to see something more interesting, let's say something like that. So let's try more elements, and I think I could go with more elements, but OBS Studio and the other elements are getting a lot of process, so now we're talking. Let's add a little wind into the back of the mesh in order to simulate the fact that we are going forward. So let's say for 3 winds, that would be something like flow 3 I don't remember if the wind was on the Z or the Y axis, but you know what, let's try the Z axis. So 0, and I thought it would be -1, and we could add to this the wind. So let's first add the gravities and the wind. Yeah, the wind is too much. Let's say 001. Oh, I took the wind divided by the wind, which gives us surely an error. Okay, so now we retrieve the wind and going back here, and let's put a wind of 0.1. So now we have some kind of particle man which is spawning a little bit of particle every time it's going. Maybe we could increase a little bit the size of the particle. Also, the particles are spawning really fast, so let's focus now on the scale system. So the particles are spawning, so this is okay. We have 50,000 particles, so perfect, but we have this little jiggy system, which is every time we are spawning some particle, it looks like it's appeared too quickly. This is because we haven't managed the scale, and I think the best way to manage the scale will be to create some kind of a ramp on the time. So for example, so let's remap the time. So we have two time, we need two things in fact. Where is my notebook? Here it is. Yes, merci Stéphane. Le monsieur en sucre, ah c'est pas mal. Je voulais faire du sable mais j'étais pas encore à la couleur. Du coup le monsieur en sucre c'est bien. C'est pas bon pour les calories mais c'est pas mal. So I need to start with a size of 0, increasing really speeds, and take to 1 and small down. So I think I would have something like this and this. Oh yeah, a smooth step might be the trick in fact. Yeah, the smooth step might be the trick. It could be really simple in fact. I was not thinking about that, but let's remap the normal time. So let's say float time scale. I would name it like that. I will start with a smooth step of our value. So we're starting from 0, and let's find something like smoothness. Okay, so this is the smoothness of our time. Smoothness of timing, I don't know. Not sure about this name. But yeah, so at first the time will go from 0 to smoothness. So this is 0, and we will use the norm time. So this could be simply be used for scaling the time at first, but if we want to manage also to have something going from 0 to 1, then keep consistent, then 1 to 0, I would say something like that. I would take this and 1 minus the smooth step also of 1 minus the smoothness to 1 by the norm time. So this could give us something like scaling up, scaling down. It's kind of a custom curve. So we still have this jiggy apparition because I think I have too much, I'm working with too much element and my GPU doesn't follow the trick. So you can see it. Now you see it working pretty well. And maybe because 4 seconds might be too much for our little guy here, so let's try something like offset going from let's say 0.5 seconds of existence to 1.5 and offset this by 8 seconds. Let's check the process in the, where is it? Analysis, profiler. Yeah, I'm taking too much time in the profiler. Okay. Not what I thought. From 0.20 to 0.25. You know what? Instead of doing this, instead of using a random index, maybe we can simply use a modulo of that. So we could maybe say I modulo of the element to be sure to have to spawn on every vertex. Let's reduce the wind. When we respawn everything, I think I need to reset also the velocity and the acceleration, because we keep the same velocity, so it might not be a proper thing. And I haven't changed where is it? Yeah, I haven't changed the wind, in fact. Where is it? Yes, this is the wind. 0.5. I don't know why it's sometimes it's reaching this. Because we use the same random for this. I think this is the problem. Yeah, looks better. Let's reduce a little bit the velocity to try see how it's behave. Okay, that's okay. I think this is what I had in mind. If we add that, it might be interesting. Otherwise, getting okay. So I was thinking about something else. Another thing that might be interesting is, in order to avoid having this strat system, might be simply to create a new to duplicate, in fact, the GPU mesh controller, and instead of having all the thing animated, we will keep only the so we'll create a new computer, of course, but the main idea is to spawn only a particle of sand on the body, and this particle will not fall down, so it will keep some kind of a body of references. So let's try to duplicate that. Copy. Oh, I paste the same value, but let's say copy as new. Okay, so I will need to duplicate this and say it would be not the 25 but the 24.2, sorry. Okay, and I would put it here. Then I will duplicate this, and this one would be the 2, and here it is. And for this one I would disable all the physics, so we would not, so let's disable this. So this is the params. So the main idea is to keep everything fixed for this one. Oh shit, the video was shut down on Instagram, so as I don't want to relaunch it, I think we would quit here on Instagram, but I will continue on on Twitch. That might be a better solution, and especially because I would be able to free some of the memory to my GPU. So as I said, I want to get this. So this one is really simple. In fact, this is that. We don't need the time scale, so it's okay. The smoothness, we don't need it. This is the size, we don't need this part. So yeah, of course we have too many elements, so we are reaching the points and where our little guy here are basically we are low in frame rate. But if we're reducing everything, as you could see now, so if we want to distribute, for example, 1 per instances, we could simply go back to our body, which is here, and see how many elements we have. 9,732. So let's put that 9,732 elements. Okay, and now we could also basically say the same for this one. And now we have the sunman, so we have the particle and the particle is falling, so we keep some consistency. We could also, but I don't think it's necessary in the compute here, we could regenerate, in fact, the index, for example. We've used it a lot of time. in order to change a little bit, but I'm not sure it's important because we will not see the difference, or it might be producing something interesting. You know what, let's try that one. Let's say float, let's say int new index would be something like random 3 using a float 3 based on, for example, the loop. So this is the actual loop. We also have oppose.w plus the loop and the index plus the loop, and we could say that this is simply multiplied by the size buffer minus 1. So multiply equal the size buffer minus 1. And then we will put this into a hint value, and we could use this here, here, here. Let's try that. Okay. Well, let's reduce a little bit the size of this one. Okay, so it's really more interesting right now. Now we can say something like this by 4, and let's try that. Okay, let's put now some color into it. Let's reactivate some of the things we have. For example, augment the velocity. And now we have something interesting. We could also augment a little bit the wind, which is here. Return to minus 0.1. And going with something with more thickness. Okay, time to focus on our little guy. So, two things. First, I want to try the shading, of course, but before that, I think I would love to also try to subdivide a little bit more our mesh, to have something more evenly distributed. So let's open Cinema 4D and let's try to create a new sub, a new KG row sub. I'm not sure about this one, but let's try that, because I think it would be enough. So as I said in the beginning, I'm not sure about my idea of the cube inside, etc., in order to reveal the body, because we clearly can see that the body is empty here. In order to get rid of this, in fact, it would be better to try to make something different. For example, I've made on another experiment a cube full of particles, and then we can subtract the sine distance field of the body inside to get a full complete body with full of particle. But I'm not sure about this one. Okay, let's stop this little guy here, and let's open our new dummy, and I think it was Neo. Yes, this was this one. So Neo sub. I'm not sure. Let's try to see if it supports a subdivision. Yeah, it does not support the subdivision. We will need to remake the rig after that. So let's try a closed surface. I think this is really too much. With this we could have something more evenly distributed, I think. We could try this one. Okay, let's export this. So new sub high, then go back to mix sabo. I will not save the C4D file. I'm not sure about using it, so okay, let's upload the character, and I think it's here. Also, I'm just thinking about it, but you might notice that we haven't at any time work with the rotation, and that's because, as you can see, we really don't need to play with it. In fact, it seems quite enough for me. Now let's try the auto rigger. I kind of like the way it's falling. Maybe we could say something like 0, 0, 0, 1, 0, 0, 25. No, we need to keep the same consistency on the size. Or might be interesting if we want to have a little bit more depth to increase in order to have some less gap, something like that, so we would have less gaps. But if we put that size for the elements which are falling, I think it would be too big. Maybe not, but yeah, I think when we go on the other side, I think it's too big. This one is better. We could have some rocks into the body and less rocks. Okay. So the chin is here. Okay. West. Okay. Okay. Elbows are clearly here. Knee are here, and the groin is here. Okay. Next. Ah, yes, it's ready. Looks okay to me. So it was a standard walk. So we had this in place. And now we can download as the FBX for Unity with skin and with no frame reduction. Okay, here it is. Let's import that little guy into our scene. So where is our Neo? It's here. Okay, so it's okay. no avatar. Let's extract the material. Okay, the same. And for the animation, it simply is a walk. Okay, and it's loop. Okay, and here are our little models. So let's import our little neo sub. Can we have the base one? So the base one is here. So it seems we have the same elements, not a problem. Again, I will open every element of the rig. I think I could simply tag all the elements. No, not all. Okay. We would need to use this. Not sure if we will use this. Okay. Looks okay to me. Go back to the controller and let's try that one. The one we want to use is this one. I haven't put any controller into it, but I need to put some controller, so let's create a new controller. This is sub high. And as we have an animation, let's put the animation into it. Okay. So, is he working or not? He's working. Cool. Go back to the controller here, and we need to put this one here, and let's try to see how it's behaved. It's kind of interesting because you can see we don't have enough element to place all this so let's try to modify a little bit our script, and in this instance let's put something like a public pool is random. By default this is false, but if it's random, we would say something like if is random is false, then we would use this. If not, we would use that. So we could simply change this value to say we want to distribute in order to have less gap. So there is more meshes to try. Okay, so let's reduce this one by, let's say, 10, and let's try to see if we can have a little guy with more elements. So the body has how many elements? Yeah, really too much. Let's try with 5, this one, and if we try to put 25,000, It's nearly, as you can see, it's nearly a complete mesh, full of little rocks with some hole inside of it. So we can take this, and we could try also to have 20,000 on this one. So let's reduce, because we want to let's try this one. As you could see, we do not see the body, so this is better if we put, let's say, 50,000 static mesh instance. Even 10,000 might be enough. I try to find a, yeah, this one might be enough, because I kind of like the way we have a little hole in it. And now we can say maybe 40,000 meshes which can fall. Okay, and I'm quite happy with this one. The run is quite beautiful. So yeah, we can focus on the shading parts. Let's try to avoid the fact that our mesh, or we could simply change it, but where is it? This size I don't want. Okay, so I don't need that part. The rotation I don't need also, but now I think we can spawn the elements directly without using any scale system. Because we are spawning directly from the elements. Of course, it could be interesting to use a little one here. So let's say something like smooth on and smooth off. Okay, so this would be the first smooth and the second smooth. So for example, the smooth on might be something like 0, 1, just to have a little bit to avoid a popping system. So something like that, 0, 0, 5 for example. So 0, 25, and this one might be 0, 1, because now we can see the decreasing, the fade out. Oh yeah, of course I forgot to change the 0 smooth on and the 0 smooth off. So as you could see now, it seems that we have a scale which is going down. Now, yeah, this is better. So it's disappearing at the end. So this is clearly better. So this is perfect. So let's try to find something to play with as a PBR free texture. So we have this one, and again I will go to this. I need to start this, and the second one was, I think, this one. No, 3D texture, I think. I'm not sure about this. Let's try first of all to see if we have some sand into it. The sand here is more interesting. Okay, let's go to some bricks. So the gem is not interesting. Floor. Rocks. What's the difference between rock and stone? Stones are more blocky things for architectures. Thank you very much. I've just seen the chat now. So rocks. Finding some rocks. This one might be interesting, but little too white. But it's really interesting. We have a rough, you have an ambient occlusion. So the ambient occlusion might give a lot of things. Oh yeah, this one, the canyon rock. Rough rock, okay. A little bit too wide, but I think this 2-1 might be really interesting. Oh, the rough rock also. Yeah, diffuse normal. Yeah, we have the ambient occlusion. I'm really looking forward to use the ambient occlusion because it will give a sub level of. Let's try this one. It's really colorful. When I said colorful, I mean it's not white. Okay, so let's download this. Go back in our little guy here, and let's try to add more texture, and let's add a little rock. First of all, we can also try with some texture we already have. For example, maybe the agate, because we haven't used the agate right now, but it could be really interesting. So where is it? While the one is downloading, it has an occlusion here, it has this and a rough. So this is the first one, and let's put this on the second one. Okay, and the rough, and let's see how it's behaving. Let's say 0 1 0 1 for the reflection, and as you can see, we could have a lot of beautiful reflection directly into it, but I'm not sure about this because we cannot clearly enjoy the fact that the agate has a really beautiful depth and texture and everything. So, but yeah, if you click pause, you could see the agate is really beautiful, but we cannot enjoy that part. It kind of look like some diamonds falling. Might be interesting, in fact, to going with something with a little bit of reflection into it. But as I wanted to work with sand, let's try with sand. So let's open this, okay. Maybe we could use something else. What do we have in the abstract? Yeah, it's okay. Let's open the folder. Show Explorer. Okay. Go back and say send. No props. That's why I love creative coding, because sometimes you have an idea. This one was playing with sand, but sometimes it's just saying that you just need to say, okay, sand is good, but by putting another texture it's really different, and I kind of like that. The occlusion, this, and let's put this back into it, and let's try that. Does it work or not? So clearly the reflection is not good, because it doesn't need to have a reflection. So let's say 0.8 for something more diffuse. And it will definitely need to be more emissive in order to clearly now in the reference I've shown you. So basically for the one who's following, I was showing in the beginning of the stream a reference from Spider-Man 3 with the Sandman. So basically we are clearly on the good path to the reference, but does it match the things we want to make? It's a little bit, can I say that? It's interesting, the movement is really interesting, but too dark, too really not interesting. Even the white is more interesting. So let's change that part. Let's try some of the texture we already have. Something like that, the occlusion of this, and the roughness of this. So it could be some kind of little diamonds. So we could reduce this. sample as 0.1 and add a little bit more emission into it. Okay. What kind of color could we have? Maybe we could create a simple iridescent system. On this scale it could be working. The main idea would be to use noise to sample some kind of gradient color directly into the quartz. So let me show you. I'm thinking about that because I'm not sure the rock is really interesting. I think having a little bit of reflection into it might be more interesting, and I was thinking maybe something like a diamond, because another references, when you've made the other experiment, my wife said it looked like the diamond girl from X-Men, so yeah, it might be interesting. So yeah, let's try to put a sphere if it want to look like you need to work on the okay, so here it is. Where is our shape? I don't really know where is it. Where is the sphere? It's here. Why is it small? I don't know, but let's work on that. So let's get rid of the discard, in fact, because we don't use it. So now we're using in.color. So in.color is basically from the vertex shader. So if I don't initialize it with a white color at first, I would have a black color. So I need to say something like o.color, o.color at first is equal to a float for which is 0, which is 1 1 1 1. Okay. While the shader is compiling, let me change this music. Okay. Okay, so this is the quartz. We have some kind of reflection into it, so if we want to increase the reflection, we could see it now, and we could simply change this, and let's say the quartz is basically something with a blurred reflection. Yeah, now it's better. Okay, it's taking part of the normal. We could also increase the reflection on this, so it's a little bit smooth. I kind of like the look-alike of this. And if we want a better sphere, we could also change the mesh renderer, which is here, and put the other sphere we have here, which is smoother. So now we have a really smooth. So yeah, what I want to try is basically in the shader we have this, so this is okay. We have a ramp, this is okay, but we could sample the ramp in something different. So let's say we want to have a noise value, okay, which is basically the S noise of in.data.w, which is a random value, so right now we don't have it. In dot data dot oppose dot xyz, again it's not ready right now, but then we can add the UV. So in dot UV main text, and the time dot y with a little bit of scale to small a little bit this. So let's put that in the color right now there to check, and let's comment all of the render. So we could end up with some kind of a noise. Oh yeah, in.data.oppose does not exist, it's in.oppose. And in.data, I think, yeah, I think it's not in.data, it's in.oppose where we have the random value. Okay, we need to keep the structure as a graph. So yeah, of course we use this sphere, so we have a problem. So yeah, so yeah, of course I know why we have this again. We need to remember that the noise is sample between -1 and 1, so we need to say that noise is simply equal to noise multiplied by 0.5 plus 0.5, so we would have a sample value between 0 1. Okay, so now we have a little noise here. We still have something strange, which is basically the, I think it's come from that. So the simplex noise seems to have some mistake inside of it, so that's why we have some kind of really strats on it. So now it could be better. Okay, so I will change it by a simple noise, and of course I know that. Okay, I now need to, I can re-put that here, and let's say multiply by 25 for example. Let's go back to the util in order to be sure how this function behaves. So yeah, it's take a float 3, so not a problem. Yeah, now you see the noise. Okay. So of course 25 is too much for a scale. And my main idea is to curl this one on himself, to getting something with more difference inside of it. So by curling this, then we could use this as a ramp for our iridescence. So maybe something like, let's say +3 UV noise could be equal to this. Okay. And we could simply say this dot x is equal to the cosine of it, and this dot y could be the sine of the component. So of course I think I will end up with something clearly white because I haven't rescaled my noise. Oh yeah, we kind of starting seeing something else. I don't remember, maybe on the code pen I would find on a reference I've made a few years ago, because I don't remember my my way to do that. So it was on another code Vember where I made some kind of distorted noise, and this is the one I want to retrieve. I think I didn't use the, so it might be the zebra or pillow. I think it's pillow. Yeah, this is pillow. Okay, let's change the view, going back here and try to can I minimize this? Okay, no, I can. So here's an old experiment I've made, and how can I rotate my noise? How did I make the curl? Yeah, I made a proper curl here. I've used a curl noise and the domain. Oh yeah, it's a curl noise and the domain warping. So domain warping could be too much process for instances. Yeah, again I've used a domain warping, so I need to change that. Maybe I can use a curl. Let's try the curl. Does the curl use? Yeah, the curl use the S noise in fact. Let's try the curl using UV noise just to check. Because the curl is between -1, I need to remap it. So let's try that. let's keep only one value, because the curl is a xyz component, of course. So yeah, let's go back here. Okay, so clearly not what I want. Let's rethink a little bit our system. So the main idea is to curl the x and the y axis, I think. So something like float to curl uv could be a float to of the main text. So let's find something like the cosine of the main text multiplied by the time and the sine of the uv main text. So in dot uv main text by the time. Let's try this one just to check how is it. Correct number of arguments here, curl. Oh yeah, forgot this part. Dot x and this is dot y. Okay, we have some things that kind of look like a curl. But as we're multiplying the time, maybe we need to add the time, not multiplying, so it will offset a little bit and not scale. Okay. And now of course this, which is basically an offset, could be scaled, for example, by 4 in order to get some kind of curl or bending. It's more like a bending. What things can we have to curl that. I want to try to curl things. So how can I say that? Maybe a noise of a noise. Maybe that was the idea. Okay. Do we have a noise 2D for this or not? Yes, I have a noise 2D. So let's say float x is equal to the this of in dot uv main text plus time. Let's try to do the same with this one. Scene of the noise, and of course it would be y and x, and for the time it would be time dot y, and then it's x and y. Oh, and I've put the same here, so I need to change it because now I have only a noise on one axis. Clearly not what I wanted. I'm starting considering instead of having a noise, I could simply create a fake noise, in fact. So I could basically use a noise, but I will create a fake noise for the XYZ. So let's try that. I don't want to lose too much time. Oh my. Chris Badge seems to have shared something. Okay. So yeah, I'm thinking about generating my offset myself. So the main idea is take a little texture here, so I think 265 by 265 might be enough, and by that I would add some yeah, I need to fill that. Okay, and now I could add some lever into it. let's deform this by a zigzag, not a zigzag, no, sorry. Let's deform this by something like that, or not. Yes, this is the what I was looking for. Okay, now let's rotate this, create another deformation. Okay, we could add some blur into it before, just to try to smooth the value a little bit, so something like that, and then a level or a contrast might be enough. Let's say some contrast. Where is it? Okay, so the main idea is to pick the X on that one and the Y on that one. Using an offset. So let's try and name this a noise. Okay. Go back here. Let's create a new things here, which is not that but a noise ramp. Okay. I'm clearly going to the fastest solution, I think. So let's say something like that. So plot X could be something like Vx, okay, something like text 2D of the noise ramp at float2, and we will use a frac in .uv .x, and because this is one color only, I would offset the main text by the time multiply by 0.25 and using the fractional number only for the y-axis. So now I have uvx and uvy. Okay, and we could basically scale this two little guys. So I will say this uv noi, uv2 noi for noise. I could say simply uv2 noise because I have the space here. It was a float through of these two little guys here, so we could scale them later, and then we could say something like this, multiply by 4. wait until it's compiled again, put, oops la, yep, here it is. Take our little guy here, put the noise texture into it, and now we have it. You can see how it's behaved. We have some kind of noise into it. Maybe we can simply take this for the offset using the random offset per instances. You know what? Let's choose also a random 2. Simply. To random. Okay. In dot oppose dot w. I think we would need to get rid of the clamping. Unexpected token. Yeah, of course I might be writing. I think I've written a parenthesis. Okay. So now we have that. Of course it's not tiled. I know that. Let's disable the MIP mapping to avoid the sim. So now we have that. If we say 1, it might do the trick. So now we have that little guy here. Say 1. And let's add the time to everything. So it's not only the Z component that would go, but also the XYZ. Okay, go back here. How can we offset this little guy? By going inside the UV. So now we're moving. So something we can do now is basically use this noise as the value of this little guy here. So where is our ramp? Is here. If we put the ramp into this, this would be something like that. Okay. And let's see if we have something near an iridescent ramp. Something like that might be interesting. And of course the main idea now is simply to change this ramp using osmos steps. So let's say float iridescent Erie factor. I will name it this Erie factor. And again, I would need something like float thickness, float point. Let's say the point would be PTS would be something like 0.5, and float the smoothness, that could be 0.1 and 0.1. Okay, and now this is something like a smooth step of our PTS, so our point minus the thickness multiplied by 0.5 minus the smoothness to the PTS minus the thickness multiplied by 0.5 to the noise multiplied by the inverse of this little guy here, which is basically 1 minus the smoothness of PTS plus the thickness multiplied by 0.5 PTS plus the thickness multiplied by 0.5 plus the smoothness to the noise. Okay, which is called noise. Okay, and now we could say something like the ramp, okay, is basically a linear interpolation between a float 3 0 0 0, so a dark value, to the himself, to the ramp, based on the Erie factor. Then this we could add to the end a little ramp into it to check if it matches. Smoothness undetermined smooth step. Oh yeah, I say smoothness instead of smooth step. Cannot implicit convert. Yes, it's a fix 4, so I need to put everything into RGB. Okay, and now you can see it a little bit, but you can see it. I can also multiply this by, let's say, 4 in order to increase the value of that. Multiply by the ramp might be also a way to give some color. Of course. So let's say fixed, so it's fixed, so fig 3 albedo. So we could put this little value here, and it's not with a image, so let's take this and put in that, so we could use it also by using the linear interpolation. So let's say something like layup of course the albedo to the albedo multiplied by the ramp plus the ramp by 2 to the noise. Let's try this little guy. Unexpected O here. So yeah, the multiplication is clearly not the solution, as you could see, because maybe I could multiply by 1 plus the ramp, just to be sure to avoid multiplying by a smaller value. And if now we put the fractional component of the time, you could have another kind of animation. I think I would add the ramp also to the emissive. Something like product emission could be added to this. This could be something interesting. And let's keep that here. Oh, I click on played, which I don't need. Okay, time to reactivate everything. It's clearly not perfect, so I'm not sure we will keep it, but because it's really a small thing, might be good enough for producing some kind of effect on the color side of our little guy. Okay, so now we need to, in this one, need to put the same value on the two of this. I'm not sure, but yes, this is this one. Okay. Yeah, as you could see, we have a lot of it on it. So if you want to change it, I think this would be something like, we need a smoothness like that. And if we want to reduce the pattern, which is here, I think it would be better to change. I think the time is unnecessary here on the z-axis. It's not necessary here. Maybe we can say something like that. Or it could be better to simply try to get a noise basically based on the element and try to simply change the value because it's too much here. So you know what, let's go back to something really more simple. We'll really try to do something which is not necessary here. So we will keep the ramp and we would simply create a noise for each one based on the position by 1. Oh, I forgot the albedo, which is basically that. In fact, RGB multiplied by the occlusion multiplied by in dot color dot RGB. It's a little bit of iridescent, so if you want to increase, you could say something like this as a range between or a float, in fact, float, and this would be a noise ink. Okay, noise ink. So let's put this float here instead of the alpha test, might be good enough. Okay, and the noise ink of 5, for example. Oh, and of course I need to change the two of them. Zero one zero one zero zero one 0101001 03. Okay, we will keep this one. We need to put a little bit of this to the albedo, in fact. And because I know what I'm doing, I will already add a range saying that it would be the ramp emission. So this is it, and this would be the ramp emission, and I will simply multiply this by the ramp emission. So I could add a little bit of emission directly because I think the color is a little bit too it's correct for the albedo, but for the emissive, when you have some color, it needs to be a little bit poppy, you know. So for this we finish, and I think for this one it's okay also. Okay, seems to be okay, and it's recompiling again. Okay, so now we have this two little guy, and maybe we can put the emission a little bit less prominent. And now we have it. So if you want to push the emission on the ramp, you could see it here. I need to modify the two of them. Let's say noising curve 1, and okay, I could see we also try to create some hole inside the noise. I think by saying simply we want, if we say something like noise is simply equal to the fractional, oh yeah, I'm writing English. So if we say the fractional part of himself multiplied by 4, for example, we would have some kind of stratification inside the noise, so it could be also interesting. Yes, and now you can see what I mean by giving more into this. Let's simply multiply. 4 is really too much, but if we try to simplify a little bit, we could say something like that. And now we will need to relaunch. Okay, it's nearly done. Let's finish this a little bit. The opposite is basically the position, so this is okay. But maybe instead of the position, it could bind the vertex. Let's try O dot oppose ici dot xyz will be equal to v dot vertex dot xyz. I think it if it will be in model space, we would have the same thing, so it would be a nice test to see how it behaves. Yeah, you can see now it's clearly in model space because we have that. So we will need to multiply this. Okay, let's try that. So let's say it's a float 4 or this plus props dot oppose dot w, which is this part in fact. Okay, then we could simply say that o dot oppose dot xyz is equal to the multiplication of the matrix, which is props.tmat by float 4 of o dot oppose dot xyz and 1. I want to get rid of the last component, which is basically a random number, and I want to keep it. So we could get rid of the fact that when the shape is turning, it's kind of look the same. And now we are talking. And now we can say something like that. Okay, I think we have it. It's not as perfect as I wanted. Also, I'm not quite fan of the color. I think we could find a better ramp. In fact, double ramp might be interesting. You know what? Let's try that. Instead of using that, I would use in dot oppose dot w to check which one of the ramp in terms of the random value we want to try. Because we made a lot of double ramp and it worked pretty well. And we haven't used double ramp since a while, so let's try that one. Okay. I think I prefer this one than this one. Not sure why. Maybe because too much. Yeah, let's go with this one. I think it's better. Okay, so I think this is all for tonight. This was an idea I had in mind since a while. It's pretty simple because Basically, it's a particle man, but taking the fact that we are going with such a precious rocks and having these nice movements and folds and texture, I think it's pretty interesting. So I hope you like it, and I hope to see you tomorrow for code number 25, in fact. So we are reaching the end, and I wish you all a good night until then. Bye everyone.